Very good morning, students. Unit 14 Biomolecules. Unit 14 Biomolecules. In this session, I am going to teach monosaccharides, structure and preparation of glucose. Structure and preparation of glucose. The first one is here, monosaccharides. Monosaccharides. The monosaccharides are carbohydrates that cannot be hydrolyzed further. That cannot be hydrolyzed further. So, the monosaccharides are also known as simple sugar. Simple sugar. The general form of monosaccharides CnH2O n For example, glucose in N is equal to 6. So C6H12, 6 into 2, 12, O6. Okay, so monosaccharides example, glucose, fructose, ribose, erythrose and etc. Right? This is general formula CnH2O n times. The many of the monosaccharides are available, but about only 20 of them in occur nature. Are you right? So many of the monosaccharides are available, only 20 of them in nature. Are you right? Okay, so the example of monosaccharides, glucose, fructose, erythrose, ribose and etc. Do you write? The monosaccharides are further classified based on the functional group. The functional group is aldehyde. The monosaccharides are called aldoses. In functional group is keto group. The monosaccharides are called ketoses. Are you right? The aldoses and ketoses are further classified based on the number of carbon atom. Right? In aldoses or ketoses contain the 3 carbon atom. So 3 carbon atom, the presence in the monosaccharides, the 3 carbon atom the monosaccharides are called trioses. In 4 carbon atom, presence of 4 carbon atom in monosaccharides, detroses. In 5 carbon, pentoses. In 6 carbon, hexoses. Are you right? So, the example of monosaccharides. The number of carbon atom 3. The number of carbon atom 3. In functional group is aldehyde. In functional group is keto. Right? 3 carbon. So, functional group aldehyde. In aldotriose. Okay, so the sugar name of the sugar aldotriose. In functional group is ketone. So ketoses. So number of carbon atom 3. So ketotriose. Aldotriose. You right? The example of aldotriose. Okay, so CHO bond CH2 CHOH bond CH2OH. glyceraldehyde. Okay, so glyceraldehyde. The general formula of aldose and ketoses. The general formula of aldoses CHO bond, CHOH and N times secondary alcohol and one primary alcohol, CH2OH, right? The N is equal to 1, 2, 3 and 4. The monosaccharides contain 3 to 8 carbon atoms. The monosaccharides contain 3 to 8 carbon atoms. Okay, so more than 4 carbon atom contained monosaccharides exist as cyclic form, and 7 and 8 is rare. Okay, so unstable monosaccharides. Are you right? So N equal to 1. So minimum 3 carbon. So N equal to 1. So CHO, CHOH, CHOH, CH2OH. Are you right? In ketose, general formula of ketose, CH2OH, C double bond O, right? And CHOH N times and CH2OH, right? N is equal to 0, 1, 2, 3 and etc. Right? N equal to 0. N equal to 0, right? So N equal to 0, CH2 OH bond, C double bond O, C double bond O, so N 0, so tan 0, then CH2 OH. Are you right? So the aldol triose, example glyceraldehyde, D-glyceraldehyde. D-glyceraldehyde is a aldol triose, right? Ketone triose, the functional group is ketone. How many carbon? 1, 2, 3. So ketone triose, dihydroxyacetone, dihydroxyacetone is a ketone triose, right? And next, the number of carbon 4. The number of carbon is 4. Aldehyde, ketone. Aldehyde and ketone. So aldodextrose, ketodextrose, aldodextrose and ketodextrose. Okay, so example of aldodextrose, erythrose, right? Erythrose. Okay, so 1, 2, 3, 4. 4 carbon atom. Functional group is aldehyde. So erythrose. D-erythrose. And ketodextrose. Erythrolase. Erythrolase, right? So the structure of erythrolase, CHO, CH2OH, right? C double bond O and CHOH bond, CH2OH bond, CH2OH. So N equal to 1. So N equal to 1. In general formula, N equal to 1, right? So 1, 2, 3, 4. 4 carbon, functional group keto, right? Ketodextrose, example erythrolose. And 5 aldehyde, keto. Non-aldehyde group, right? So 5 penta, So aldopentose. Aldopentose. Right? And ketopentose. So example, ribose and ribulose. Okay, so how many carbon? 5 carbons. 1, 2, 3, 4, 5. 5 carbon. So first aldehyde is a functional group. So H, OH, H, OH, H, OH, CH2OH. Right? D-ribose. So D-ribose is a aldopentose. Are you right? So D-ribose is a aldopentose type of monosaccharides. And ketopentose, right? So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 5 carbon. 1, 2, 3, 4. 5 carbons, right? So presence of keto group CH2OH and CH2OH. Okay, so N equal to 2. HOH and HOH. Ribulose. Okay, is a ketopentose, right? And the number of carbon atom is 6. Carbon 6 in functional group aldehyde, functional group ketone, the functional group aldehyde, aldohexose. The functional group is ketone, ketohexose. An example of aldohexose, glucose. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right? So 6 carbon, an aldehyde group, HOH, OH, HOH, and HOH, CH2OH. Okay, so N equal to 4. So N equal to 4, right? So glucose. So example for aldohexose. Right? Ketohexose, fructose. 1, 2, 3, 4, 5, 6. Okay. Double bond O, CH2OH and CH2OH. N equal to 3. Right? HOH. Right? HOH. HOH. Alright? Fructose. Right? Okay, students. The next one is glucose. The glucose is a simple sugar. Okay. The glucose provide more energy source as them. The glucose is a most important and most abundant sugars. The human blood contains 100 milligram per deciliter of glucose. The human blood contains 100 milligram per deciliter of glucose. So glucose are also known as blood sugar. Right? The glucose present in the honey, sweet, and fruits such as grapes and mangoes. Are you right? The glucose present in the combined form of sucrose, right? Cellulose, starch, and etc. You right? The preparation of glucose. Preparation of glucose. The first preparation, the hydrolysis of canned sugar. Hydrolysis of canned sugar, sucrose, C12H22O11. The hydrolysis of canned sugar, sucrose. Hydrolysis of sucrose in presence of dilute sulfuric acid in alcoholic solution. The presence of dilute sulfuric acid in alcoholic solution to give glucose and fructose. To give glucose and fructose. C6H12O6 plus C6H12O6. Right? So glucose and fructose. So sucrose is a disaccharides. Sucrose is a disaccharides. Okay, so hydrolysis will give 2 monosaccharides. So sucrose is a disaccharides, right? The second preparation is a commercial preparation from starch. C6H10O5 in N times starch. The commercial preparation from starch. The hydrolysis of starch. The hydrolysis of starch. You write in presence of dilute hydrochloric acid at a high temperature 393 Kelvin and high pressure 2 to 3 atm. You write gives N-glucose. N-glucose. So starch is a homopolysaccharides. The homopolysaccharides, hydrolysis with the homopolysaccharides to give the same type of monosaccharides. So starch gives glucose in N number of glucose. Right? So starch is a homopolysaccharides. Right? The next one is the structure of glucose. So very important one. 5 mark questions. Structure of glucose. Structure of glucose. The structure of glucose derived based on the following evidence. The first one, the elemental analysis. The elemental analysis and molecular weight determination. The elemental, okay, so carbon, hydrogen and oxygens are present in the glucose. The elemental analysis to identify the element in glucose, carbon, hydrogen and oxygen, and molecular weight determination show that the molecular formula of glucose is C6H12O6. C6H12O6. Are you right? So, second point, the glucose, okay, the reduction of glucose with concentrated hydriodic acid and phosphorus at 373 Kelvin. The reduction of glucose with concentrated hydriodic acid per phosphorus at 373 Kelvin to give N-hexane. N-hexane, right? N-hexane and 2-iodohexane. Hexane. Are you right? The reduction of glucose with the concentrated hydriodic acid per phosphorus at 373 Kelvin to gives the combined form of N-hexane and 2-iodohexane. Say N-hexane is a major product, right? 2-iodohexane is a minor product. Thus reaction indicates glucose contain 6 carbons. Glucose contain 6 carbons of linear chain. So no branched chain. Are you right? So to give N-hexane, so no branched carbon presence in the glucose structure. Are you right? Thus reaction indicate so does not having branched chain. Okay, bonded linearly. Are you right? So all carbons are linear carbon. 1, 2, 3, 4, 5, 6. 6 carbons are linearly. So no branched chain. Are you right? So in third one, right? The glucose reacts with the hydroxylamine. To give oxime type product. Oxime. Are you right? So glucose. CHO, CH double bond O and OH 4 times and CH2OH. So reacts with the hydroxylamine H2 N bond OH, right? So will gives glucose oxime. So CH double bond NOH plus CHOH 4 times and CH2OH. Glucose oxime. Right? So glucose reacts with the hydroxylamine to give glucose oxime, and glucose reacts with the hydrogen cyanide to give cyanohydrin. Right? So glucose reacts with the cyanohydrin in presence of sodium hydroxide. Okay, so cyanohydrin is separated H plus and Cn minus. Cn minus is a nucleophile, right? So O minus to give CHOH, right? Positive and negative. Cn bond CHOH 4 times bond CH2OH. Are you right? So glucose cyanohydrin. To give glucose cyanohydrin. Okay. So these two reactions are indicates the glucose contain carbonyl group. Carbonyl group only reacts with the hydroxylamine and HCN to give oxime type of products and cyanohydrin type of products. So the either aldehyde or ketones are present in the glucose, right? So the next one is identify the aldehyde or keto group are present in the glucose. Okay. So point number 4. Point number 3. So both aldehyde or keto groups are present in the glucose. Okay. The next point number 4. So aldehyde or keto group are there in glucose, right? So identify the aldehyde or keto group. Point number 4. Okay. The glucose oxidized with the glucose oxidized with mild oxidizing agent, bromine water. Bromine water is a mild oxidizing agent. Okay, so the glucose oxidized with mild oxidizing agent gives gluconic acid. Okay, the aldehyde group is converted into carboxylic acid group. Right? So the glucose oxidized with the mild oxidizing agent will give gluconic acid. Gluconic acid. Right? So the aldehyde group only oxidized with the mild oxidizing agents. The ketone does not oxidize with the mild oxidizing agent. Are you right? So the aldehyde group presents in the one end of the carbon chain. This reaction indicates the aldehyde group presents in the one end of the aldehyde glucose. Are you right? So these reactions indicate the aldehyde group occupied in one end of the carbon chain. Okay, so the glucose oxidized with strong oxidizing agents such as nitric acid. Nitric acid, the glucose is converted into glucoric acids or saccharic acids. So COOH and CH2. OH 4 times bond COOH. Okay, so aldehyde group and primary alcohol group both are changed into carboxylic group. Are you right? So glucoric acid. Glucoric acids are saccharic acid. Glucoric acids are saccharic acids. So that reactions. The that reactions indicates the glucose contain primary alcohol. Primary alcohol in other end of the carbon chain. Are you right? So other end of the carbon chain. Are you right? Okay. So fifth point. Fifth point, conformation point. Okay, so the aldehyde is present in glucose. The conformation point, the glucose oxidized into gluconic acid in presence of Tollen's reagent and filling solution. Are you right? So the glucose is oxidized to gluconic acid. The glucose is oxidized to gluconic acid in presence of Tollen's reagent. Tollen's reagent is the ammoniacal silver nitrate. Ammoniacal silver nitrate. The Tollen's reagent reduced to silver mirror. Are you right? So silver mirror. The Tollen's reagent reduced to silver mirror. The glucose is converted into gluconic acids, right? So the tolerance reagent only oxidized with the aldehyde group. Okay, does not oxidized with the keto group. So confirm the glucose contain aldehyde group, the functional group aldehyde. So glucose is a aldohexose. Are you right? Okay, and tolerance reagent, filling solutions. Filling solution, copper sulfate and sodium potassium tartarate. Copper sulfate and sodium potassium tartarate. The blue cupric oxide is reduced to red cuprous oxide. Okay, the glucose is converted into gluconic acid. Glucose is converted into gluconic acid and red precipitate of cuprous oxide. So filling solution reduced to cuprous oxide. Okay, and oxidized with gluconic acid. Glucose to gluconic acid. Okay, so the conformly presence in aldehyde group in one end of the carbon chain in glucose. Are you right? And sixth point. In sixth point, okay, so glucose reacts with acetic anhydride. Glucose reacts with acetic anhydride to give glucose pentaacetate. Okay, glucose that reacts with acetic anhydride to give glucose pentaacetate. It gives glucose pentaacetate, right? So CH3COOH. Okay, so plus CH3COOH. Okay, the reaction carry on 4 times,
5 times.
So 4
the 5 acetic anhydride.
Are you right? And
5 acetic acid.
4 acetic acids. 1 glucose pentaacetate. Okay, that reactions indicate the glucose contain 5 hydroxy group. The glucose contain 5 hydroxy group. Are you right? In 7th point, so glucose is a stable compound. Cannot easily dehydration is occurs. Cannot easily occur dehydration. You right? So glucose is a stable compound. Cannot easily dehydration. Cannot occur easily dehydration. Are you right? So the all hydroxy group presents in different carbon atom. Okay, so stable compound, so cannot easily dehydration, does not have more than hydroxy group in each carbon. Okay, so all hydroxy group presents in individual carbon, different carbon atom. Okay, so OH, 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 right? OH and OH. Right? That's reaction indicate 5-hydroxy group. Okay, so glucose is a more stable compound. Cannot easily dehydration is occurs. Okay, so does not contain gem dihydroxy group. Are you right? So glucose does not contain gem dihydroxy group. Gem dihydroxy group. Gem diol means the carbon contain 2 hydroxy group. So does not occur 2 hydroxy group in glucose. So each hydroxy group bonded with a different carbon. Are you right? So the 8th point, Fischer projection. In a Fischer projections, the structure of glucose is deformed. Okay, so the Fischer identify the glucose structures, right? The glucose is deformed. Capital D means the hydroxy group attached to the asymmetric carbon. The hydroxy group attached to the right side of the asymmetric carbon, the furthest from the carbonyl. The furthest from the carbonyl. Are you right? So D means the hydroxy group attached to the right side of the asymmetric carbon. Asymmetric carbon, the furthest from the carbonyl. From the carbonyl. Are you right? So glucose is a D. D. The glucose to rotate the plane polarized light in right hand side clockwise direction. Okay, so glucose is a D plus glucose. Glucose is a D plus glucose. Are you right? And glucose functional group is aldehyde. How many carbons are there? 6 carbon. So glucose is a aldohexose. Glucose is a aldohexose. Are you right? And so the plane polarized light rotate in clockwise direction. So rotation is dextro-rotatory compound. Glucose is a dextro-rotatory substance. So glucose are also called dextrose. Glucose are also called dextrose. Are you right? So the glucose contains 4 chiral carbon. Okay, so chiral carbon means the carbon bonded with 4 different atom or molecules. Okay, so H, OH, CHO and other, right? So chiral carbon 2, chiral carbon 3, chiral carbon 4. Okay, so number of chiral carbon. The number of chiral carbon in glucose is 4. The number of chiral carbon is 4. So number of article isomerism 2 power n, 2 power 4, 2 into 2 into 2 into 2, that is equal to 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. The possible optical isomers of glucose is 16. The number of optical isomers of glucose is 16. Are you right? So 4 carbon, 4 chiral carbon, asymmetric carbon 4. Okay, so possible optical isomerism 16. Are you right? Functional group is aldehyde group. 4 secondary alcohol. 4 secondary alcohol and 1 primary alcohols are available in glucose structures. Are you right? Okay, so the glucose is a aldohexose. Aldohexose type of sugar. Aldohexose type of sugar. Are you right? Okay, so thank you students. The glucose structure derived based on the following evidence. Are you right? Okay. Thank you, students. We will meet next class. Thank you.